Lecture 8, Part 3. Physical properties of polyethylene. You can see modulus of elasticity, temperature coefficient. Tensile strength is 13.8 megapascal or 2 KSI. Advantages are tough, durable, weather resistant, chemical and moisture resistance, excellent electrical properties. Application of polyethylene are sheet plastic, membranes, liners, pipe, electrical conduit, tanks, bottles, etc. Polyurethane. Physical properties are sensitive to temperature and RH. Low elastic module, 400 KSI. Advantages: resistant to chemical, lightweight and resistant to wear, closed cell material when used with the foams, cryogenic performance. In building and construction, polyurethane are used to make high-performance products that are strong but lightweight, perform well and are durable and versatile. Polyurethane products also can help enhance the aesthetic design of homes and buildings. Polyurethanes are formed by reacting a polyol-chemical compound with a type of chemical called diisocyanates, which are mixed to create different types of polyurethane applications. In building and construction, polyurethanes are used to make high-performance products that are strong but lightweight. Polyurethane is a key ingredient in several types of high-efficiency insulation materials, sealant and adhesives used in home and building construction. Polyurethane are used in the manufacture of high resilience foam seating, rigid foam insulation panels, microcellular foam seals and gaskets, spray foam, durable elastometric wheels and tires, such as rollers, coaster, escalator, shopping cart, elevator, and skateboard wheels, automotive suspension, bushing, etc. Strengths from the start. Polymer composites. So, polymer composites. Also, we can say fiber reinforced polymer, a composite material made of a polymer matrix reinforced with fibers, offers a great alternative for strengthening metallic structures, especially steel structures such as bridges, buildings, offshore platforms, pipelines, and crane structure. Composite materials in the form of surface reinforcement externally bonded non-metallic strips and consists of fiber, carbon, and can be also aramid or glass bonded together with a polymer matrix, epoxy, polyester, or vinyl ester. Composites with thermoplastics. Glass fiber composites, 40% weight. Monofilament, braided strand, and shop fiber. Polymer can be polypropylene, polycarbonate, polyethylene terephthalate, polybutylene terephthalate, and nylon. Typical properties of fibers. For aramid, carbon, and steel, you can see that carbon and aramid have modulus 5 times higher than steel. So steel have 200 gigapascal and carbon have 800 megapascal, and aramid has 170 gigapascal. And also you can see strengths of steel 400, and aramid and carbon have 3000, 5000 megapascal. So what is the FRP? FRP stands for fiber reinforced plastic or fiber reinforced polymer, also you can say. FRP is used in structural shapes, repair materials, or as reinforcement for concrete. FRP is a composite material consisting of artificial fibers and cast in a resin matrix. Materials used in FRP. Fiber type glass, polyvinyl alcohol, carbon, aramid. Resin types epoxy, polyester. Fiber type and resin type. Resins are thermosetting. Manufacture of FRP rods. Pultrusion enables a high percentage of fibers to be included in the cross-section. Braiding creates surface deformations which enhance the FRP to concrete bond. Hybrid rods. One of the type. Engineer properties of FRP. High tensile strength. On average, the tensile strength of FRP is 10% to 500%. 100% greater than steel. Low modulus of elasticity. With the exception of carbon rods, fiber-reinforced polymer has only 1/10 to 1/2 the modulus of steel. Linear stress-strain relationship. Very important characteristics. Applications of fiber-reinforced polymer. Reinforcement bars for concrete, pre-stressing tendons for concrete members, fiber-reinforced polymer sheet can be used to increase flexural strength in weakened or under-designed members. Advantages of fiber-reinforced polymer. Fiber-reinforced polymer reinforcement is an engineered material that shows great promise in the future of civil engineering. The system for strengthening of building structures vary depending on the type of consolidation required. Reinforced render method. Where glass fiber-reinforced polymer meshes connections and accessories are combined with lime-based mortars to obtain collaborating reinforced render capable of improving shear, flexural and compressive strength of masonry. Reinforced reporting method, where stainless steel cord connections are used to consolidate exposed stone masonry. The system helps reinforce masonry diffusely and successfully while preserving the original look. And the next type is fiber-reinforced sheeting method with glass fiber-reinforced polymer or carbon fiber-reinforced polymer waves, sheets and bars, particularly adapted to consolidate beams, pillars and columns, and any other spots where masonry requires local reinforcement. Of all architectural elements, arches and walls made of stone or brick, be they bearing or not, are the most prone to degradation and stress caused by seismic events, changes in acting loads and foundation sinking, which cause the structure to lose its original mechanical properties because these elements are of great historic and architectural value. They need to be consolidated in a non-invasive, compatible and consistent way with regard to their special features. FiberNet developed two different methods of intervention. The reinforced render with fiber-reinforced cementation matrix where glass fiber reinforced polymer meshes, connection and accessories are combined with preferably lime-based mortars to obtain a thin collaborating reinforcement capable of improving mechanical strength diffusely and homogeneously. And the fiber reinforced sheeting method. Where glass fiber reinforced polymer or carbon fiber reinforced polymer weaves are used for reinforcing individual spots, ideally recommended for oddly shaped arches and vaults. The aesthetic superiority and the general structural characteristics of fiber-reinforced polymer systems have been recognized by many scientists like Angelo Di Tomasa, Irsisa Isayenko, etc. And of course, following international organizations, the International Federation for Structural Concrete, American Concrete Institute, Japan Building Disaster Prevention Association, and others. Thank you very much. And now, vocabulary. Polymer, monomer, plastic, thermosetting, thermoplastic, epoxy, polyesters, polyurethane, polyvinyl chloride, polyethylene, composites, fiber reinforced plastic, concrete, cement, component, aggregate, hydration, kiln, gravel, furnace slag, expanded clay, fly ash, pumping, clinker, mixing, placing, pot furnace, tank furnace, annealing, shaping, melting, amorphous, silicate, silicon, sodium, potassium, calcium, lead, zinc, lime, oxygen, acid, flint. Alloy, blast furnace, or corrosion, malleable, ductile, electrolysis, carbon, aluminium, brass, iron, copper, steel. Bonding, alloy, shear force, atom, neutron, proton, electron, stiffness, elasticity, melting, fracture, creep, fatigue, crack. Building materials, environment, concrete, metal, steel, timber, insulation materials, polymers, clay, glass, gypsum, bitumen. Transparent, bendy, rigid, soft, hard, liquefied. So have a nice day. Bye.